Ever wondered what it takes to create one of those incredible high-performance drones that zip through the sky? It's not just about slapping some parts together. It's a symphony of precision engineering, advanced materials, and intricate electronics. Today, we're going behind the scenes to see how these amazing machines are born. It all begins in the digital world. Engineers sit at powerful workstations using CAD software to sculpt every curve and angle of the drone's design. They run complex simulations, testing the frame for stress points and analyzing how air will flow over the propellers. This virtual testing ensures the drone is both strong and aerodynamically efficient before a single physical part is ever made. Next, the design comes to life, starting with the frame. A massive 5-axis CNC machine carves a perfect mold from a solid block of aluminum. Inside a sterile clean room, technicians carefully lay sheets of shimmering carbon fiber into this mold. The whole thing is then sealed inside an autoclave, where intense heat and pressure fuse the layers into an incredibly light yet rigid monocoque frame. Once cooled, another CNC machine trims the excess, and it's hand-finished to perfection. Now, for the power. The heart of a drone's propulsion is its brushless motors. We see thin silicon steel sheets stamped out to create the stator, which is then flawlessly wound with bright copper wire by a high-speed machine. Powerful neodymium magnets are precisely placed inside the rotor. After assembly, each motor is spun on a dynamic balancing machine, tweaked until it runs completely free of vibration. In parallel, the carbon fiber propellers are crafted using a similar molding process to the frame, ensuring they are perfectly matched for performance. But motors need instructions. That's where the electronic speed controllers, or ESCs, come in. A bare-printed circuit board gets loaded into a pick-and-place machine that, in a blur of motion, populates it with tiny components like MOSFETs and a microcontroller. The board then glides through a reflow oven, where a wave of heat solders everything into place in seconds. At the very center of it all is the flight controller, the drone's brain. This is a multi-layered circuit board created through a process of photolithography and chemical etching, building up complex pathways for electricity. Again, the pick-and-place machine does its magic, adding the main processor, a gyroscope to sense rotation, and an accelerometer to sense movement. Another trip through the reflow oven and the brain is complete. Of course, none of this works without juice. The power source is a lithium polymer battery. We see impossibly thin layers of anode, cathode, and a separator being stacked and folded together with a polymer electrolyte. This delicate assembly is then sealed into a flexible, durable pouch, creating a lightweight and powerful battery pack. To control the drone from the ground, you need a solid communication system. We see the radio receiver and transmitter being built. The focus here is on the circuit boards and the precise soldering of antenna components, which is critical for achieving a long and reliable signal range. But modern drones are more than just motors and a frame. They're packed with sensors. We get a micro-level view of a tiny MEMS gyroscope being etched onto a silicon wafer. We see the CMO sensor for the camera being made in a high-tech semiconductor fab. For smooth video, a gimbal is essential, and we watch as its tiny motors are assembled and balanced. With the hardware ready, it's time for the software. Teams of developers write thousands of lines of code, creating the firmware that tells the drone how to fly, stabilize itself, and respond to commands. This code is then flashed onto the flight controller's processor, giving the brain its intelligence. Finally, it's assembly time. In a stunning montage, all these individual components come together. A skilled technician mounts the motors, ESCs, and flight controller onto the carbon fiber frame. They meticulously route all the wiring, soldering each connection with expert precision. Before it can take to the skies, the drone must pass a series of rigorous tests. It's placed in a special rig where engineers calibrate all the sensors, test the motor responses, and check the signal strength. Then comes the moment of truth. Its very first flight, safely conducted inside a large, netted enclosure. The final touches are applied, sleek branding and logos. The drone undergoes one last, exhaustive quality inspection, checking every screw and every function. Only then is it carefully placed into its custom packaging, sealed and ready to be sent out into the world. From a digital dream to a flying reality, it's an incredible journey of technology and craftsmanship. Thanks for watching, and don't forget to like and subscribe for more deep dives into how things are made.